page of the first derivative review packet, and I'm going to do this page with you, and I'm going to ask that you do it on binder paper or print it, and you are going to snap a photo to show me that you did this and turn it in, because this will really get you prepared for the AP Classroom problem that I'm assigning. Okay, they gave you G, G prime, H, F, all these letters. I'm not even sure what I'm going to need or when I'm going to need it. I'm going to jump right in and we'll see. Okay, so for part A, it says find the slope of the line tangent to the graph. That is a very fancy long way of just saying the derivative. Slope of the line tangent to the graph is the derivative. So for part A, they want us to find f prime of pi. In order to find f prime of pi, I'm going to go ahead and not use G, not use H. We're going to look right here. And I'm going to need some rules for this one. So to do f prime, I'm going to need chain rule. I have the derivative of the outside, leaving the inside alone, times the derivative of the inside piece. And then I have chain rule again. I have the derivative of e as itself. And then I have to multiply by the derivative of that inside piece. And there you are. At this point, I would plug a pi in. And I would be a little afraid because it looks so messy. But I see as I'm writing that I have sine of 2 pi, which is 0. So this won't be that bad. Okay, so for this one, if the College Board threw this my way, I would go ahead and write, let's see here, e to the sine pi is e to the 0. E to the 0 is 1. Cosine of pi is -1. So I have 0 plus -1 times 1, which is -1. This was an FRQ in a previous year. The answer is f prime of pi equals -1 for part A. Looking at part B, I have no idea what K is, what it means. I'm just going to jump right in and then make sense of it. So for part B, it asks for K prime of pi. So I'm going to have to find K prime. And to find K prime, I'm going to need chain rule because K is defined as being H of F of X. Reminder, whenever you heard yourself saying of, that tended to be a chain, or it is a chain. So I have the derivative of the outside, leaving the inside alone, times the derivative of the inside. At this point, I'm going to go ahead and put a pi in. I still have absolutely no idea what this means, but I'll make sense of it once I have it all down. So if I can figure this out, then I know the answer to the question. And reminder, the answer to the question is for K prime of pi. So I'm going to fill in what I know. I already know f prime of pi because I found it in part A, and f prime of pi was -1. And I'm capable of finding f of pi. So to find f of pi, I'm going to need to plug a pi into my given f function. My f function is cosine 2x, so cosine 2 pi. And then plus e to the sine x, so e to the sine pi. Sine pi is 0, e to the 0 is 1, and cosine of 2 pi is 1. So 1 plus 1 is 2. You can rewind if you need to figure out, again, where that 2 came from. At this point, I just need h prime of 2. So I'm going to go look at my given information, and I'm going to use the h graph. So if that is the graph of h, then h prime are the slopes at all of those places. So h prime of 2 is the slope of the line that would be tangent right here at 2. I think that it is -1/3. And I'm getting that from just going down 1/3, down 1/3. The slope right here appears to be -1/3. All right, I'm going to keep going. You can pause. You can come back. Part C. Part C, looks like it has a product rule component. So they will test that you know these rules, and this is how they tested it in a previous year. So for M of X, if it's defined as being a product, then for M prime, I'm going to use the product rule. So I'm going to have the first term, the first guy, times the derivative of the second, plus the second guy, times the derivative of the first. And to do the derivative of the first, I'm going to need a chain rule. So I have g prime of negative 2x, but don't forget to multiply by the derivative of that inside piece. So this is, again, a mess, and I'm going to plug a 2 in because it is specifically asking me for the derivative at 2. I'm going to plug a 2 in everywhere. So go ahead and rewind or pause because this is all about to change. So I'm going to plug a 2 in every single place that I saw an X, and then I'll try to make sense of it. So it looks like to get the answer for part C, I'm going to need to figure out what g of negative 4 is, what h prime of 2 is, what h of 2 is, what g prime of negative 4 is, and let's see if that was all given to me. So and this is getting me m prime of 2. So g of negative 4, I was given in a table. G of negative 4 is 5. H prime of 2, I'm going to use my graph. And H prime of 2 is negative 1/3. H of 2 is the y coordinate here. It's the y coordinate here. So I believe that the y coordinate here is negative 2/3. I'm getting that based on the fact that this is down 1 over 3. Down 1 over 3. So down 1 over 3, down 1 over 3. Yes, this is definitely negative 2/3. Then g prime of negative 4 was also given to me in this chart. It's negative 1. And so I just need to multiply and add to get this answer. So I have negative 5/3, and then a negative times a negative is a positive times another negative is a negative. Oh my goodness. So negative 4/3, negative 5/3, and negative 4/3. I'm going with negative 9/3. I'm talking and thinking and writing and using tech, but I'm pretty sure that that works out to be negative 3. Negative 3. Negative 5/3 minus 4/3 is negative 9/3. Okay, I'm sticking with it. Almost done. I'm cruising. You would have a time limit on a problem like this in the year that this was given. This was a 15-minute FRQ. I am going as fast as I can. Let's scroll down. Is there a number C in the closed interval such that, gosh, that sounds like a mean value theorem. So is there a number C in the closed interval negative 5 to 3 such that the derivative is negative 4? What I'm going to do is I'm going to go ahead and figure out what the algebra slope was from negative 5 to 3. Because if the algebra slope on G is negative 4, then the mean value theorem guarantees that there is an instantaneous rate of change that equals the average rate of change. So let me scroll up. I'm going to look at the given info for G, and to find the algebra slope, I just need the y coordinates. So G of 3, I was not given. Let me scroll back down here. I bet that this was negative 3 and I mistyped it. Let's assume that it was. 1 second. If it was negative 3, then I get 2 minus 10 over negative 3 minus negative 5, which is negative 8 over 2, which is negative 4. Okay, my friends, I mistyped the question. This needs to say negative 3. So what we're going to do is find the algebra slope. Even though they didn't tell me, this just sounds so much like mean value theorem that I wanted to find the algebra slope. So the algebra slope from negative 5 to negative 3, I need to change that, is the change in the y's over the change in the x's. So I went ahead and I grabbed the y and the y, the x and the x, to get an algebra 1 slope of negative 4. So the algebra slope, the slope of the secant line, is negative 4 from negative 5 to negative 3. So then the College Board asked, is there a place, are you guaranteed that the calculus slope will be negative 4? The answer is all of this work, include all of this work, and then yes, due to MVT. Go ahead and look through your notebook or your textbook to remind yourself a little bit more about the mean value theorem. The mean value theorem states that there will be at least one place where the calculus slope equals that algebra slope. Okay, once you have finished watching this and filled in parts A, B, C, and D on binder paper or printed, snap a photo just of this. I don't need the rest of the packet, just A, B, C, D, and go ahead and submit that on Canvas so I know that you've participated. And then you should be prepared to take the AP classroom assessment, an FRQ that matches this level of derivative comprehension. All right, guys, I'll see you soon.